Hi, welcome back. This is Rakesh Naik. Today we are into the fourth talk of Dr. Nishu Gupta, who is delivering on Intelligent Vehicular Network using VANET. In this series, from the author, researchers from reputed institute come forward to deliver their research work. So if you want to know about research and what people are doing around, please subscribe and press the bell icon so that you will be getting updates regularly. So without taking much of the time, presenting Nishu Gupta for his fourth talk.
Hello viewers, I once again welcome you towards the fourth presentation of this series. Here I have come up with something beyond vehicular network only, and today I am going to discuss about the emerging technologies, applications and futuristic scope of cognitive vehicular network for 5G wireless systems. Yes, 5G. So this is a brief outline of this presentation wherein I am going to discuss about cognitive radio, the multiple input, multiple output MIMO systems, massive MIMO, heterogeneous networks. Then we move on to the proposed work, the framework that we have proposed in this article, the simulations, results and the conclusions. So let us begin. As you see, cognitive radio, you may feel it is new, but actually we have been using this for quite some time. This is dynamic spectrum access. We are accessing the channels dynamically. So it's a software defined radio that can be configured and reconfigured as well to use the available channels. It utilizes the spectrum in a dynamic way. So it's a dynamic spectrum management technique. In this figure you can see different frequency bands are there, and in between these bands we have some gaps, right? So the optimum use will be when you are using these gaps, because we are already short of frequency bands, right? With ever increasing number of users, in future also we are going to fall short of these channels and resources. So the better we realize the importance of these gaps, we can utilize them in a more efficient way. So when we implement this cognitive radio concept in vehicular environment, it is known as cognitive vehicular network. It is the ability to use the spectrum opportunistically. You see, you have to check when the spectrum is available and when can it be used. So you see in this figure what are the different applications of cognitive radio technology. It can be used in emergency and public safety. It can be used in healthcare applications, unmanned aircraft systems, which we commonly call as a UAV, unmanned aerial vehicle, mobile networks, vehicular networks, as well as in smart grids relating to electrical applications. So what is multiple input and multiple output? It is a method of multiplying the capacity of a radio link using multiple transmit and receiving antennas. So I'll give you one very realistic example to it. Suppose our laptop is connected with Ethernet connection. It's a wired LAN connection. At a time, using an Ethernet wire, one laptop can be connected to internet. However, using this MIMO technique and through various applications that are available these days, for example Connectify, we can create a wireless environment and connect to various mobile phones or laptops or any networking device and get the internet connection in a wireless mode. So that is one real-time application and utility of this technology. So this works on multipath propagation. So different technologies such as 3G, Wi-Fi, long-term evolution and many other wireless and RF technologies, they are using this MIMO wireless technology. It provides an increased link capacity and spectral efficiency combined with improved link reliability. So in this figure you can see one MIMO scenario where we are having different transmitters as well as different receivers, and these transmitters and receivers, one transmitter can connect to multiple receivers like that. What is massive MIMO? It's an enhanced version of MIMO which employs large scale antenna system. It consists of multiple antennas, typically of the order of more than 200 something, as transmitting as well as receiving antenna. So we observe significant improvement in the performance over the existing MIMO systems, and some parameters such as spectral efficiency, reliability, data transmission rate, and various parameters relating to energy factor like consumption of power, dissipation, noise margin, etc. How come this technology came? It is a consequence of fast fading, distortions and noise, which can be significantly reduced using this technology. Now let me tell you one thing. These concepts of fading, distortion, these all relate to wireless propagation, and the viewers of this video should be well acquainted with these terminologies before peeping deep into this research field. Otherwise, I feel it would not be appropriate to dig in more in this field without having prior knowledge. And one of the best books that I have read in this field is T.A. Rappaport, Wireless Communication book. Another one being B.A. Forozan, one of the best books each and every person working in this field should go through. Now we move on to HETNETs, heterogeneous networks. So there are two types of networks, the homogeneous network and the heterogeneous networks. Networks using different layers of the OSI model, they come under this category of heterogeneous networks, means layers more than one we are using in this technology. So wireless networks with nodes of different coverage sizes and transmission powers are covered in this technology. It consists of various macro cells as well as small cells, see, of the order of 10 to the power -12 to 10 to the power -15 meters. So now we are moving much beyond the nano level. So some high power nodes are there, some low power nodes are there. The high power nodes are typically used in urban scenario or maybe in rural areas, whereas these low power nodes, they have small coverage areas and they are used to cover throughput improvement. So these are one of the most promising low cost approaches. Green communication, maybe many of you might be knowing about green communication, cooperative communication. These are the upcoming fields, and many researchers are working toward this field, which helps in energy saving. The consumption of energy and power is significantly controlled using this green and cooperative communication. So in the proposed work, the work that I am presenting in this presentation is already been published in a Springer journal, the link which will be given to you in the description section of this video. So a potential cellular architecture that covers various emerging and promising schemes of wireless 5G network has been proposed. By using the scheme of dynamic allocation of the radio resource in a heterogeneous network, a promising and highly efficient solution has been deduced. So the focus of this work is on making the most effective use of the QoS parameters, the quality of service parameters, you know, the throughput, the end-to-end delay, the channel utilization, the energy efficiency and the spectral efficiency. So we aim to optimize most of these parameters. So in this series, this article has been published, and it can be downloaded from the link provided to you. You can see a MIMO scenario over here, which employs a universal mobile telecommunication system, some WiMAX long-term evolution, and wireless LAN antennas. So we have tried to relate it to cognitive radio in a vehicular environment. So the simulations are performed in Network Simulator version 2.34. These are the parameters. As previously discussed in my presentations, these scenarios are user-defined scenarios. However, we are not free to take any value. We have to test for their applicability. For example, that this bit rate, if you are focusing on safety applications, this bit rate of 6 Mbps becomes very crucial. Again, this simulation time, I would recommend the researchers, particularly in this field, not to keep the simulation time less than 150 seconds, because it doesn't give you the accurate results. Simulation time of 150 seconds is a must and is minimum, you know. So this antenna model and this radio propagation model, these things are user specific, and based upon your algorithm and your proposed work, you may opt for different models also. Simulation area, it's totally up to you. However, it should be realistic. Please make note of that. So we have compared different networks based upon different performance matrices. If you go across the article that has been published, you will come across all these parameters. What are these optimum values? What have been deduced out of this? Right? So these are different parameters under consideration with respect to different types of network: WiMAX, WLAN, UMTS, and long-term evolution. So at present in 4G technology, we are using LTE. Once we enter into the 5G world, we will come across dynamic spectrum access, we will come across cognitive radio concepts, the primary user, the secondary user concept, which has yet not been among us. So some of the results I am showing you over here. The weights generated for different parameters. You can see 4 different networks are compared, and on the basis of different performance matrices, we can see how much weightage is given to which network. This weightage means the importance, the longer time of connectivity. So in order to conclude, we propose a framework for heterogeneous networking as a promising solution towards 5G wireless network. So factors like cooperative capacity in a heterogeneous network as well as in the multi-hop property of radio networks, they form a promising and effective solution. So millimeter wave communication, famously known as terahertz wave, means typically of the order of 300 gigahertz to 3000 gigahertz. So once you move towards 3000 gigahertz, you come across a 3 terahertz range. So if you convert it towards the wavelength conversion, it will be millimeter wave. So we are moving towards communication between the devices, the waves between which are of the order of millimeters. So in future, we shall move towards research domains like remote radioheads, pico node and femto node, which will further enhance the performance of these heterogeneous networks. So this is just an insight for the upcoming researchers that there lies a huge scope of research towards this field, because as we move towards 5G, it again opens new possibilities towards the future generations to come. So thank you very much. Stay tuned. Keep watching.